let's talk about discontinuity. If a function is not continuous, then it's discontinuous. In Calc 1, you're probably going to talk about three types of discontinuity: asymptotes, jumps, and holes. This first one we're going to do is a jump. These almost will exclusively happen with piecewise functions. If I look here, the limit as x approaches a does not exist. It's not the same from the left and the right. However, if I say, what is f of a, I can find a value, in this case, y. Because the limit as x approaches a of f of x does not equal f of a, then the limit does not exist. Secondly, let's talk about asymptotes, another type of discontinuity. Asymptotes are those invisible lines, in this case I drew it in with red, in which your graph can't touch. My sophomore year of high school, my math teacher told me, math is your friend, and you can never touch your friend's asymptote in public. In Calc 1 and prior, you're probably dealing with breaking the first rule of math, don't divide by 0, and this is how you're going to get asymptotes. If I look at this graph, the limit of g of x as x approaches b equals infinity, but there is no g of b. It does not exist. Because they're not the same, therefore, it is discontinuous at b. The final type of discontinuity is a hole in the graph, or removable discontinuity. We're going to talk about this a little bit more when we talk about algebraically solving limits. So here, I have at c, notice how there's a hole in my graph. Because there's a hole, h of c does not exist. And because it does not exist, and the limit of c, because it's approaching the same from the left and the right, equals y2. They don't equal the same thing, therefore it is discontinuous at c.